This is lesson 47 of the Quantum Mechanics, a mini lecture series, Schrodinger's equation part 2. So I was deriving this Schrodinger equation from the previous video. We got something like this, minus k squared psi. Now we can use from before, if you recall, E is, well, I should say, for the k here, we know that it's got something to do with the energy, right? So let's write, this is another way to write the kinetic energy of an object, p squared over 2m. Okay, that's just the same thing as writing a half mv squared. Okay, where p is just the momentum of an object, mass times velocity. And p, if you recall from a previous video, it's just h bar k, right? In terms of the wave number, okay. So that's equal to brackets h bar squared k squared over 2m. Let's rearrange. Let's make substitution, I should say. We'll get this. Okay, where the k squared has been replaced with p squared over 2m. Okay, using this expression here. Okay, so we took the h bar squared over 2m to the other side. It's just using algebra. Having taken the partial derivative with respect to x position, let's take the partial derivative now with respect to time. So do this. So let's take this expression here and take the partial derivative. Where is it? I should write here. E to the I kx minus omega t. Let's take this wave function here. Let's take the partial derivative with respect to time. Here's what we get. We will get, so we're focusing on this, minus omega, so I should say minus I omega, because I times minus omega t, right? I omega ae to the I kx minus omega t. Okay, which is just minus I omega psi, right? And we can use E equals h bar omega, right, from before. We can write it like this, do something similar as before. I h bar d psi over dt is h bar omega psi, which is just E psi. Okay, that's the energy. So put in E for the energy. Okay, we've taken the I over, substituted this. Okay, if we arranged for omega, plugged it into here, then we shifted it a bit and get this expression here. So in other words, from this, right, I'll show you the working out. Omega has been replaced by E over h bar, okay. So we get d psi over dt is just minus I E over h bar psi. Okay, then you take psi over and the I over, and you end up with this. Okay, whenever you take a minus I over, it becomes plus I. G equals, and that's just, and we're left with E, which is h bar omega. Got the psi here. And from before, that's just defined as being the energy. And we can rewrite this, so we can generalize this, I should say, where there's both kinetic energy and potential energy, right? So the E psi is written as p squared over 2m psi plus v of x psi. V of x, that's potential energy. That's how we write potential energy in physics. And in the next video, I will arrive at the actual Schrodinger equation. But for now, the energy of the particle is a sum of kinetic energy terms, a kinetic energy term, and a potential energy term.